Okay, now that the kernel's compiling, we'll go ahead and go over today's subject, which is with distributed file systems. Just try and stay awake, I guess, for this one. It's a little boring, unfortunately, but it is necessary because it is one of the more important advanced topics in operating systems is how do we actually seamlessly share files in a large environment. So this is going to be used in a lot of, well, definitely supercomputers will be using something along these lines because they need massive storage. Also, servers are going to be using some type of architecture similar to this as well. So it is important, but it is distributed file system. So yeah, background, naming, etc. We'll talk about all those things. Basically, we want to make sure you understand the issues with distributed file systems, and then be able to at least see the trade-offs between it, especially stateful and stateless, and then how replication works. And we'll do a quick look at the Andrew file system, which is a very de facto academic example of a distributed file system. All right, we call it a DFS, so it's not depth first search, it's distributed file system here, just to make sure your acronyms are straight. Basically, you're going to distribute the implementation of some type of file system. It's going to manage all your different storage devices, but it's going to be, your file system will be composed, of course, differently remotely located smaller storage spaces that are hopefully combined in some way that is useful. And there's usually, what, corresponds between constant storage spaces and set of files. Right. Great, thanks. Normally, when you look at these, you have three things: service, server, and client. Server and client should be fairly obvious because the server is where it's actually serving the file, and the client is what's trying to manipulate or operate on the file. The service is what we just talk about as they call it a software entity. You think of it as the code or the process that's running, some function or code with all the different clients. The client can interface it with different commands. Usually you want to make these we'll talk about transparent in a moment. But they'll have a bunch of commands to create, delete, read, and write. And yeah, you want it to be transparent, aka you want the client to not be able to really know the difference between a local file and a file that's on the network, because you want to make sure that the users, everything is as seamless as possible. Okay. So the naming is how you map from, local to physical objects? Logical to physical objects. Multi-level mapping, file that hides detail where the disk is actually stored, sure. So you may be able to, here's the local file, but it's really mapped to some other level on some other machine. And a transparent distributed file system will hide the location where the network file is stored, so the client only sees a local file.
Nothing.
How was that transparent?
It didn't come up with stars, and I typed my password wrong, so I got confused.
Yeah, it's confusing. But why is that transparent?
Oh wow, I knew my password. Yeah, that's.
I don't know why it does not. I agree with you completely. And we're gonna go on.
Oh,
okay?
It's like a ghost, so you can't see it.
Yeah, it's like a ghost is transparent. That's a great explanation. I'm going with that. So you have location transparency. They really should have chosen a different word here. I agree with you completely. File name does not reveal the file's local storage location. All right. I mean, it sounds more like location encapsulation or something, but we'll go with transparency. And then you have independence. File name does not need to be changed when the file's local storage location changes. Right. So if you move it around, you're still pointing to the same thing. Okay, that's great. So if you're going to name something, let's go ahead and take practice here. We have good old server over here.
I think I see the confusion. I think think I see the confusion.
Yeah.
So the definition of transparent, easy to perceive or detect. Synonyms, see-through.
Question.
Yes.
How do you delete the Git thing if you accidentally put it in the wrong folder?
Just remove the whole directory.
Clear, crystal clear.
How do you do that?
rm-rf space the directory.
It's unbelievable.
Oh no, I'm sorry. I'm looking at two different definitions. I'm sorry. One definition is allowing light to pass through, and that's where the synonyms are clear. The other one is easy to perceive or detect. Oh no, it's still got clear and crystal clear synonyms.
So the client may have a file over here, file A, and we want to somehow have this thing reference that guy over there. So how could we do that? What could we call this thing so that if you had another file A located on
Server.file A.
server.file A, so that's location.file A. Great.
Or colon.
Okay.
Actually, let's use 2 colons.
Does that make you feel better?
Yeah.
Okay.
That's the only thing I know what the actual term for is.
What is that term?
You're putting me on the spot.
I
It's
totally.
the
Well,
scope resolution
you
thing.
said it. You
Yeah.
you just begged the question, so I asked it.
Scope resolution thing.
All right. What's another thing we could do?
We could.
Say that file A can't exist on the client.
I like that solution. That's one of my favorites. All right, can't exist.
Doesn't happen.
Is that a good solution?
Yeah, sure.
Sure. Okay. All right. We'll run with that for now. All right. Location. So you're changing the full file name to be the server and then the file name, so it knows the map over there. That's what.
I guess a third solution would be local files are named local.file A.
Okay, that's just this in reverse. Another thing you can do is you can do mounting, where you have some directory and everything in that directory is really mounting to this over here, and then you can put all your files in. So that's something similar.
So that would be renaming it server slash.
Yeah,
file A.
yeah, you're mounting the whole directory. Yeah, it's considered different, Chris. All right, let me figure out where the rest are. File name by combining their host name.
Easily readable.
Yeah, it is. If you look to the right.
Yeah, you just look over there, man. So file names are a combination of their host and local name. Haha, just like that. Good job. Attach remote directories.
Could people online see your board?
No, that's what you get for being online.
They can use their imagination.
Yes. Attach remote directories to local directories. So that's the whole mounting thing.
Move to the left screen.
Total integration of file system components. Global name structure spans all the files and servers unavailable. So, all right. Basically, it enforces what you actually said that second time, where once file A exists on this server, it can't exist on the client anymore. So good job. All right, I think we got all 3 of them. And if the server goes down, then those things just disappear from your file system.
Good lord.
You okay, Matt?
It is being clicky, but it's good.
Wow, is there no eraser? So remote,
So would a race condition exist?
that is a great question. What do you think?
Yes.
Okay, good.
What happens if you create file A on the client or on the server, but the client does not get the server update until after file A is created on the client? Bad things happen.
Yeah, so option 3 is kind of complicated, isn't it? Because you have to maintain consistency throughout all the machines in your entire system.
Okay, well, if file A exists on the client and we find a file A on the server, we rename file A on the client to file A local.
Okay, that may get around some things, unless there is some update in between that you need. I don't know if I like this solution of using wipes for this board.
How do I tell if I copied the config or that config file?
You copy it from the Lab 03 directory, CD.
Yeah, I did that, but how do I make sure it copied?
Secure copy.
And then,
Because I typed that in, and then I typed that in, I guess that makes all the stuff come up, maybe, but I don't see it.
did you copy it over?
Yeah, I did. I typed that in, like right up there.
Okay, now so
it
it's
should be
there.
there.
Yeah, so do make menu config, you need to load it. Make sure you load it. All right, so remote file access, before we start talking about your error that you pointed out, that's definitely an issue, 100%. What do we have here? Remote service mechanism is one transfer approach, so you do it by retaining recently accessed disk blocks in a cache, so that repeated access is to the same information we handle locally. So before we start talking about your consistency issue, we're going to talk about caching, because there's, hopefully you can see, a huge performance issue if every time you need to access a file you need to go on the network. Well, if you can store it locally, then maybe you can just make your changes locally and then eventually write them back out. So first off, if you don't have the data, you get it from the server. Access is performed on the cache copies. So it files identified one master copy residing on the server machine, but copies of the files are scattered in different caches. What they're basically saying here is, while the server has the master, you may have different pieces cached in different locations, and that's perfectly fine. But then you have cache consistency problem. We need to keep everything consistent with the master file. So there might be some type of system we need in order to enforce that. Y'all see the consistency problem?
Yeah, we ignore it.
You ignore it,
Mm-hmm.
but you see that's an issue?
Mm-hmm.
Okay, good.
Okay, so ignoring it wasn't the answer. We're gonna cache it.
No, that's what we're doing.
Cache the cache.
Do solution software, you're supposed to ignore it or cache it. All right. So nice thing of using disk caches. So you can use disk caches or main memory as the cache. So if the file is cached on the disk, it's more reliable because when the machine goes down, hey, look, it's still on the disk. That's good.
Caches on the disk are maintained?
When you turn your machine off, yes. Because it's still there when you turn it off. It's non-volatile memory. When you boot back up, you can say, oh, wait.
Is it really a cache?
Yeah. I mean, the cache may be invalid, or the data may be too stale, is the word I'm looking for, but it's still cached. Cache doesn't have to be just in memory, Chris. You can cache anything.
But is it really fast cache? Not fast.
Your hard drive is faster than the network.
That is true. Unless you have a
Tape.
fiber optic connection.
Not even then. Once you get a big network, you have to go through all those switches. It's going to take forever. Main memory, obviously it's going to be faster. Also, you can have workstations that are diskless. There are ways to have all these machines boot a network off the network, so they pull in the kernel and everything from a remote server, and you don't even need to have a disk, and it just mounts everything over the network. So that actually allows you to have diskless systems, which back in the day was a good thing because disks were slow. Nowadays, solid state may not be that big of an advantage as it used to be. But there's still some nice properties because now you don't have to worry about any caching on your hard drive. Obviously, data can be accessed more quickly because it's in main memory. Definitely a performance speed up. And what we got?
Which is a lot of memory.
Sure. So you buy more memory and less disk space, hard drives. Server caches are in main memory regardless of where user caches are located. Yep. Okay, cool. Cache update. We talked about write through, right? So your regular caches, if someone writes to it, it's going to write through to the main memory. The nice thing here is it's very reliable because it waits until your main memory or the server has the write completed. But the problem is there's usually poor performance because that means you have to write through the network and then come back. The other one is delayed write. You may think of this more as write back from architecture. Basically, it's written later, usually either at some interval or it's done once the cache needs to be purged. Or maybe the server says, hey, have you made any changes so I can update myself? Any number of situations can arise. Very poor reliability, because if your machine crashes and this cache was in main memory, it's now gone. So those can be very poor situations. Let's see, variations, stand cache at regular intervals, and then write on close, aka when you close the file, write everything back. Yeah.
Well, what happens if two people have it?
So that's a cache coherency problem. In general, if someone's writing to a piece of data, you want to make sure that only one.
Oh, we use locks.
Yeah, you use locks. So only one person is the owner of the file at that time and can write to it. Everyone else can still read from it because they can either pull data from it or just.
But they won't be reading what he's writing.
That depends on what your policy is.
Right.
If you're sharing data and you want to do a write update, you would update his cache, or if you want to do ownership, then the person writing to it invalidates everyone else's cache. Either way will work for cache coherency. Or option 3 is
We just ignore it.
Is your Linux thingy done? Because mine's done surprisingly fast.
let's find out.
It took like 5 minutes.
Yep, mine's done.
Cool.
Isn't that better?
Yeah,
Good.
just like 20 times better. Actually, more than that, like 30
So
or
watch
40.
the Thursday video, not the Tuesday video.
You got it. I may not even upload the Tuesday video at this
I
point.
wouldn't. Well, for the classy stuff.
Yeah. All right. Okay. Any other good questions?
No, only bad ones.
Only bad ones? All right. Caches in NFS, very common. You have your server, maybe a memory cache with a write through, and then your workstation has a write back with local disk that's write through. That sounds great. The advantage here, write back's pretty fast, but it's right through here, so it's always updating its disk space, that way if the server fails or the workstation goes down, when it comes back up, it'll at least have, hopefully, the latest right there. Or maybe not. So consistency, we talked about this already. Locally cached copy of data needs to be consistent with, well, does it need to be consistent with the master copy?
It depends.
It great answer. So it should be. Client can initiate the validity check to make sure it's happening, or the server can initiate it. That way, if someone needs to be owner, it invalidates everyone else. All right, what are we going on here? In caching, many remote access is handled efficiently by local cache. Most remote access will be served as fast as the local ones. Okay, sure. Servers are contracted only occasionally in caching. All right, yeah, it makes sense.
Yeah.
Okay. Yes. Oh, I see what it said. Caching is superior with infrequent writes, because if you're reading a lot, then it's a lot better. But you want to do it if you're doing a lot of writing, then you want to make sure you have better remote access capabilities. Sure. Thanks. That's all this is trying to say.
TLDR.
Yeah, that was the TLDR system. Okay.
Continuing on.
Before we go on, I'm gonna make a nice picture. Well, actually, do you all know the difference between stateful and stateless?
Sounds familiar.
One has a state and the other does not.
Whoa. So if you were doing a connection via file between your client and the server, and there's file A, and we'll just say it has a mounted partition with file A right there. How would these behave differently if it was stateful or stateless? Actually, this picture already enforced one version of it.
Isn't that stateless? Client always has file A.
But there's a state between it. So the stateful version, what we got, stateful service. So that's where the file client opens it, maybe does whatever it needs to, holds on to the open for a while because it's stateful, it is open. The server knows that currently the client is doing something, and then maybe it closes it. Why do we do this? Hopefully it's a performance increase, because once it's open, the client can react to different things that are happening without having to close it and reopen it, close it and reopen it. You okay, man?
Yeah.
This is opposed to a stateless system where the client would do everything in one chunk. Like it says, I need to read this bit from the file. So the server would open the file, read it, close the file, send the data over. Yeah, voids by making each request self-contained is probably the better way to do it. There's no in-the-middle reactions. Better, the way I like to think about it is if it's stateless, then it's an atomic, you can consider them atomic operations. This whole thing happens, now the whole thing's been changed, and you're done with it. While state full connection, you would open it, and it may do things in the middle while the file's still open. No need to establish and terminate a connection by open and close operations. What are the advantages and disadvantages here? Yes.
Stateful, you have to keep doing things. So for each thing, if you're doing a lot of things to it, you'd be like, nah. But if you have a state, you could just do all the stuff you want to do.
You avoid starvation with stateless.
Right, because all the operations are essentially atomic. So you just do them, the server just
Other clients
doesn't.
can still access the file.
Right, it just keeps doing them one at a time. But yeah, if someone is holding onto the file in a stateful situation, yeah, you may have another client trying to get to it. But then what's the advantage of using a stateful connection?
When the other client does get to it, you know it's got the latest and greatest.
That's okay, it's got the latest and greatest. But it's really performance, because once the client opens it, the server leaves it open. It doesn't have to open and close and do all these extra operations. It just does everything on the fly. Or it keeps doing all the operations on demand, might be a better way to put it.
Or as I put it, yeah.
Yeah. All right, another problem is failure recovery. So stateful server loses all its volatile state and crash. So you got to be able to recover. But with the stateless server, the effect of failure is almost unnoticeable because your situations are pretty much considered atomic. So it wasn't like anyone had the file open anyways. You just put the server back up and you don't have to recover. Penalties for using a robust stateless server, longer request messages because everything's self-contained, so the client has to wrap all the overhead in each single request. Usually it's slower request processing because there's more of a round trip happening. I mean, the server has to do all the calculations, get the information sent back. Additional constraints composed by, yeah, there may be some extra things in the design. They're just saying that if you actually sit down and do the details, there's a couple of extra things that happen. Some environments require stateful service. So let's see, server-initiated cache validation cannot provide stateless service since it maintains a record of files. Right. So if you're using a cache validation, yeah, there's state right there. You can't get around that. The way Unix does it often makes it stateful because you must maintain a table that maps all the file descriptors. So there's always state in that situation. All right, let me stop here. We're almost done now.